I think I'm recording this. Are you able to see my screen on your end?
Not yet.
Okay, just a minute. Let me try to share it. What about now? Good. So we are going to start. Let me just get into Pornhub very fast. So an SVM algorithm is used to classify data using using what using we're going to see how it classifies data that is based on the categories. If you see something for 2D for 2D what for 2D data, you will find it use something we call the boundary line. For 3D data, it is something we call uh, the boundary plane. And for ND features, it uses something that we call the hyperplane. So I want us just to, let me just open a new collab here. So today I want us to use a very popular data set that is called, let's see that, it's called Iris. Let me just have SVM. This should be SVM. Yeah, this is SVM. Let's call it SVM underscore. So there is these data sets that I want to import. Um, Let me import pandas. Just a minute, I import these data sets. I want to import this data set from sklearn datasets. So we import it as from sklearn dot datasets. We want to import something for iris. So Iris is a data set that has flowers information, and in this data set, the flowers are divided into three types. Maybe let us just load these. Let me just try to load these and see what we have. But basically, this data set has flowers data. Uh, so let's load that and see what it has. So you notice that today I've changed something because we are no longer using a CSV file. In this case, I'm using a dataset from the SK. The sklearn has a repository that is called datasets, and it has a number of datasets within the repository. So in this case, we are just using the iris dataset. Before even we get to see the content of this dataset, I would like us to check the iris iris dot that is, let's check the feature names. I think I can just delete this for a minute. So with this dataset, what is recorded in these datasets? In this dataset is the sepal wing. You know, you guys, I think you can remember the parts of a flower, right? Can you guys remember the sepal and the petal part of a flower? Thumbs up if you can remember these. Yeah, I can see Mary. Can I remember Amos also, Rodovan? What about the rest? Yeah, I can see Joseph Kilu, Carl. Yeah, 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 yeah. So in this data set, it has these data of different flowers. That is the sepal length, the sepal wing, and the petal length and petal wing. Um, so in this case, we are going like to classify flowers based on these variables. So let's say maybe you are given a sepal length of a certain length, a wing of also a sepal wing, and petal length of a certain flower. And then based on that, you are told to classify that flower in the classifications that we have. I think you can just maybe try to check the classifications that we have in this data set here. So let's see the target. We have iris.target, iris.target, iris.target. I think I can get into target names. Uh, and you can see we have three classifications in this data set. And we have the classification that is called setosa, and we have a classification that is called vascular, and another classification that is called vaginica. Who of us is familiar with these classifications? The thumbs up if you're familiar with this kind of classification. I think the guys who took is it biology, they can tell us more about these classifications. Personally, I never did biology, but I understand that we have these three classifications in this data set. So based on the sepal length, the sepal wing, and petal length and petal wing, we can classify a certain flower to a certain category, either a setosa, a vascular, and a vaginica. So nobody is familiar with these classifications. Thumbs up if you are familiar with it. I can see most of us can barely remember what we barely remember what you learned in biology. But anyway, we're just going like to to do the classification. Uh, I'm going like to get into details of what Sitosa is and what Vascala is and what Vazinica is. All you want to know in this lecture is just they're just classifications of flowers based on sepal length, petal length, and the petal what the petal wing. So you can also maybe check something like the iris dot what iris dot target. Let's see what we have in iris dot target. And you can see we have a series of zeros and one. So basically what these numbers means is that whenever you see a zero in your data set, you basically know that that one is a Sitosa classification. Whenever you see a one in a row of data, you notice that you record that that is a Vascular category. And whenever you see a 2 in the target column, you notice that that one is a Virginica. That one is a Virginica uh, category of our data set here. So basically, that is what we are going like to do today. We are going to do some event visualization of these using scatter plot so that we can have the we can see the how this is visualized using the scatter plot. So, do you have any question up to that point? Okay, thumbs up if you are together up to that point. Yeah, I can see most of us we are okay with that. So I'll not touch the theory part as we start this, but as we are coding, we are going like to I'm going like to maybe go through some of the theory part that we have in these SVM algorithms. Because I think yesterday the linear regression model is quite it's quite simple in its implementation. But when we come to SVM, there is a part of theory that we need to understand. And even for it to work very well, you need to understand things such as something we call gamma regularization of the parameters that we have. So this is something that we are going to cover as we continue. And even maybe check terms such as what is when you hear someone talk of hyperparameters turning. So those are some of the things that we are going to familiarize with. But basically in SVA, I think we said that SVM is a we said that SVM is basically a supervised machine learning algorithm that will classify data by finding the optimal. We call it optimal line or the hyperplane that might maximizes the distance between the categories of data that we have. So, like in this case, we have three categories. So, like this now, SVM will try to categorize our data. That is that is based on using, I mean, using we can use a boundary line, or we can use we can use this we can use the hyper, we call it the first we have the plane for 2D. In fact, for 2D, what we call it, for where we have 2D features. And you can use something that we call now a hyperplane, where we have more than two, I mean more than three dimensions, or more than three features. So in this case, this data is just quite it's quite organized. It isn't a complex data set. And in this case, we're just like, in case where we are just comparing the sepal length and sepal width, we are going to use a boundary line, because we just have two features, which is a 2D or a two dimensional. It's a 2D array. Also, in cases where we are trying to compare petal length and petal width, also we are going to use a boundary line, maybe two, so that we can so that we can check the support vectors in that case. But let's get into it. I'll start with what we have here. You notice that I'm importing these. That is from sklearn.dataset. I want to load the iris dataset. This is what we call the iris dataset. And you can see I'm setting that one to a certain variable here. That is iris is equals to load underscore. That is the iris dataset. So if I was to print the iris, let me just try to do that. Let me just have iris here. If I just happen maybe to run these, you notice I'm getting a series of numbers. In fact, this one is a dictionary. You can see the dictionary has data, and the data is represented into in an array format, right? So this is the data that you are going to, or this is the format. Anytime you load a data set from the sklearn dataset, this is what you get. So it's upon you to do what, to format it in a way it can you can use it in your algorithms. So what we are going to do, we are going to convert this one into a data frame. And I think you guys, you know how now to convert a dictionary into a data frame. I think we, in the, is it last but one assignment, where you are required to convert dictionary into data frames. So it's just that quite easy. So we are going to have pd.df data frame, and then we are going to pass the data that we have here. Then if maybe, let me just try to remove the column part, and run these. Let me just try to do a df here. Yeah, let's see what we have. I think I should rerun these. Good. I don't know why this is taking so much time to execute. Let me just have it here. So you can see what we have here. Let me just pick dot head. So you can see the kind of data frame we have. Oops. This data frame doesn't have the headers, or what you call the column names, right? So we just have the index that is on the x-axis and on the y-axis. So it is upon us to put the column names, right? And that is why I use these columns is equals to iris dot features underscore names, so that at least now we can have the we can name our columns. So it always good to learn this, because it's not every time that you're going to be given a CSV file. You can be required to load data from elsewhere. So so for you now to put the columns names, you just have to pass the columns that is equals to iris dot features names. So if now we try to execute this again, let's have dot head. It's a function. So if you try to run this, I think it's taking so much time to run. So you notice that now our data set has now the column names. That is the sepal length, we have the sepal wing, petal length, then the petal wing. So that is the essence of having this column parameter here. So after that, I think we can get into adding some columns here, because you notice that with this data we just have the data itself, but we don't have the target. Where is this? We don't have the let's see this. We don't have the target, right? The target column in this data set. So I want us also to learn today how you can add a column here within this data set, and it's very easy. So let's do that, so that you're able to use this data set. So can someone remind us how we were adding a column? Who can I remember how we were doing it? Let me just try to delete this. Can you guys remember? We are trying to add a column that is called target. Who can guide us on how to do it? I think by now these basic things, they should be at your fingertips. Any person? Okay, let me just do it very fast. So we always have the df, and the column name that you want to add. In this case, is target, and then we just have to equate these two. Where are we equating these two? That is the iris dot target. In fact, it is. We can just press tab to complete this. So let's just try to run this, and even just try maybe to run df of this. That is, and see if you have managed to add a target column. You notice that we have managed to add the target column here. That is the ones and the zeros. for the classification. So there is also something else that we need to add here. I want us to map. I want us to map these target values here with what we were calling the feature names, or I mean target names. Let me just show you that. We have these target iris.target. Yeah, these names, the target underscore. Yeah. So I want us to map these target names so that where we have 0, we can have a setosa, and where we have a 1, we have the versicolor, and then where we have a 2, we have the virginica. And I'm going to do that using in fact, I'm going to add a column here that is called the flowers name. So I think we can basically do that using a lambda function. I think lambda function will help us to will help me to do that easily. So we can have let me just have a lambda function. I think it is even auto completing. So it's lambda x and then iris target names. And then I want to have this iris target name mapped to that is to the target. So it's just this easy to do it. But now we need to add this into a column. So basically we can have a df. Let me do this very fast. We can have a df. Df is equals to, and the df we can call the column flower underscore name. Let me copy these here. Df flower name, and this one is equals to, I think it should be like that. Then we need to introduce something we call the df dot apply. Apply. And before apply, I think we need to, before we apply, it's df dot target, because this is the target column. Dot apply. I think this should be able to work, and it's a function. This one is always a function, so let's have this. So what we are trying to do here is adding a column that is besides target, and then the data that will be holding that in this flower name, it's the, if we have a, maybe if we have a value of 0 on the target, we should name that one as a setosa. And if we have a value of 1, we call that versicolor. And if we have a value of 2 in the target name, we call that virginica. So it's kind of, we are trying to map the values in the target column with what with the target with their respective target names. So let me just try to run this and see if it's going to work. Hoping it works. Yes, I think this worked. Because now in cases where we have, let me just try to do this. Let me have df dot head, and then maybe we pick the first like 20 like the first 20 column 20 rows of data, just to confirm that that worked perfectly. So that's it for it. Yeah, you can see that in where we have a zero, it is the flower name is a Sitosa. That is up to the 20th what up to the row number 20. So let's just try to maybe pick the last the last maybe let's speak from we can have from let's start from 60 and see what we have. Oops. Let's see this. Let me just have up to 60. The first 60. So you notice that where also we have one, we have the flower name is versicolor. It is maybe we happen to pick the last 20. That is df dot tail. Let's maybe pick the last 10. You notice that where now we have two, it's named as Virginica. So meaning that our mapping has executed successfully. So now with this now we should be able now like to work with this data. We should be able to work with this data because now we have all the columns in place. That is the first part of the data. That is the sepal length, sepal width, petal length, and petal width. And now the target column and the flower name. So any question? Uh, any question on how we have done that? Okay, thumbs up if you are okay with what you have. Who is floating? You can just raise up a hand if you are floating. I can see most of us are okay with that. So before we do anything on these data, I would like us to divide this data, to subdivide these data into three data frames. That is the data frame on the data frame that holds a question. Yes, Stella. Stella, is it a question? Sorry.
Intentionally. I have no.
Maybe can you try and type because you are breaking? You can just type the question on the in-call messages. I think I'll be able to get it from there. So I was saying that I want us to subdivide this data. That is into three data frames. So that we can have a data frame that will hold the Sitosa data, all the flowers in the Sitosa classification, and a DF that will hold all the data in the vascular classification, and also the data frame that will hold what? That will hold all the data in the Virginica classification. Because you realize that I think you can just check maybe the length of Let's check the length of the data in the CTOSA. Um, Checking the length. Oops. And you notice that the CTOSA has a target value of 0. So I think it's just quite easy. I think there is a time when Rodavan, is it Rodavan who asked how you can get the sum of all. I think you were, at that time we were dealing with FIFA data, right? Asking if you can get the sum of all the players with a certain value, right? This is how you do it. In this case, we are trying to check the length of the CTOSA data, or the sum of all the flowers in the CTOSA data. So it's just using the length function, and then you notice that we are passing in that is df, and in the df we want to have the df dot target, where target is equals to 0. If we run this, you notice that we have a value of 50. So we have a value of 50. So meaning that out of the data set that we have, 50 rows of data is part of the CTOSA data. Maybe if you guys allow me, I can maybe check the shape of this data set. Yes, I can see we have 150. That is 150 entries or rows of data. So meaning that out of 150, we have 50 as the CTOSA data. So we can as well as check the other categories. I think I can just try to arrange these. Have has checking. This is the length of, is it Vascala? Let me just try to check the spelling of these, because that is Vascala. So I think you can have now this one as one. Still, I'm yet to get your question. So let's try to run this. And also you can see that the value or the length of the Vascara dataset is also 50. So let's have the last dataset here. So I think I can just copy these to save on time. This is called, is it Virginica? It should be Virginica dataset. And now we can just change this one to maybe something like that is true. So you notice that this data set is divided into 3 equal parts. That is in all classification. So these are some of the information that we are now deriving from this data set that we had. I think by now you know how this data set is distributed, right? just by using these functions. So I think now we can maybe try to maybe we can try to divide these data sets, and we are going to have 3 data frames. Dividing these data sets into 3 data sets. And this is based on classification or based on category. This one is just quite easy. I think we already have it. We can use this. That is the df0 is equals to that is the data set that has 0, and the df1 that will hold the data set that have 1, and the df2 will have the data set where we have 2. So I think now we can maybe try to do some visualization. Let's have a scatter plot. Scatter plot should we start with the petals? I think you can start with petals. We see how they are distributed. Let's start on petals. Petals on df0. So let's have. Did we import the? Let's see this. Let me just try to import the matplotlib. So that is import matplotlib.pyplot is plt. So that now we can have we can plot these. I think someone's mic is on. Before that, let me check if Stella. Oh, Stella is in that. She's okay. It was an intentional. Okay. It's okay. So let's see what we have here. We have a PLT, X labels, PLT, Y label. We have the PLT.scatter, DF. You can just use these, but in this case now we want to change this one to petal. Let's start with this petals. I think you can change this one to petals as well. Petal. So, and you notice that we are using just the df0, and the df0, we say that it has the setosa data set, right? So meaning that from this scatter plot, what we expect from this scatter plot is a group of data points. It's a group of data points maybe in one area, because in this case we are just checking the petals on df0. So let me just try to run these. I can see already I have a problem. I don't know what could be the problem here. Let me see this. Maybe it's because I didn't run this after I had imported the matplotlib. So let me just try to rerun these. I think this should be solved now. I think also I need to run these. Oops, I'm getting an error. Let me check this. Data frame object has no attribute called target. Oh, let me just try to rerun all these. Yeah, after I run that, I should also run these. And also run this mapping. After that, I think I should now run these. You can see that we have solved that. So let's just try to draw this scatter plot. Let me see this. Kind of have an issue here again. Yeah, so let's wait for the error. We see what it is about. Seems we have errors with how we named these. We just try to run the f dot head. Yeah, I can see we have an error here. We have a typo error. It should be typo petal length, not petals length. I think I used petals. Should be petal length. So I think with that we should be able to get the visualization of that. So this is the first visualization of our data set here. That is on DF0. And now you notice that let's see the scatter that we have. That is the petal length. That is in CM, and the petal width on. That is the petal length. That is also in CM. So let us just maybe try to draw two. Let's try to do what? Let me just try to add another scatter plot here. That will have now the data on, maybe we can have the vascular or maybe vaginica. So let's have another PLT. That is dot. I think I should maybe just copy this. But in this case, I want to use the DF1. Let's pass a different color. Color you can pass maybe, let's use red. For this, we can use color blue. I think by default is blue. Let me just try to remove that. Let's also maybe specify the marker for these. I think you guys by now you know some of the parameters that we can pass here. So let's use a marker X. Let me just try to rerun this again. And now you can see that we can have the petal length and the petal width of our data set for df0 at this point. And also you can see we can see the petal width and the petal length data points for the df1. I think we can still add the PLT plot for the df2. That is now Virginica. We can use a plus sign in this case for the marker, and color we use green just to differentiate the visuals. So let's see the visual we are going to have. I don't know why it is taking so much time to execute. So this is our visualization of the petals length and petals width for each case. So uh, so you see that you notice that the distance between the distance between the first, that is it Sitosa, the distance between the Sitosa data points and Versicolor, it's quite large, right? But the distance between the Versicolor and Virginica, you can see it's kind of they are overlapping each other, right? So now we want to use a model in this case that will enable us to classify these. You know, this by we are getting this because we have already specified the data points that we want to visualize. You can see this is the df0, df1, and df2. But now we need to use a model that will learn from this data, and now from this data it is able to classify anytime you give it some data point, either the sepal length and the sepal width, and also the petal length and the petal width. So just giving it four values, it is able to classify these. It is able to classify the data points that we pass into either acetosa or acetosa, virginica, or is it called the other one is called, we have virginica, acetosa. Let me see this. That is vascular, virginica, and acetosa. So that is what we are going to do. We are going to do next, creating a model that is able to do the classification for us instead of trying maybe to. This one was just for visualization so that we can see how our data is distributed. So let's start with creating our model. I think from yesterday's lecture, you are able to create a model. It's just quite easy how we create the model. It's very easy how to create this model. So let's start with just a minute. Let me just indicate what we are doing here, that we are training support vector machine classification. I think we have a type here. In fact, this is very easy. So we are just going like to import from. Let me have this import from. I think we have this. That is import. We need to import the train and train underscore test underscore split. Can you remember what was the function of this? Someone to remind us what was the function of this? The train underscore test underscore split. Someone to remind us what was the purpose of this? Any person who can remember the purpose of this? You can just raise up your hand if you can remember the purpose of this. That is the models, that is the train underscore test underscore split. I think yesterday we didn't use these. Who can I remind us? What was the purpose of importing these? Rodavan?
I can take a guess. I think it is to kind of split the data sets. I don't know to training, and I don't know the other part. I think
Yeah,
just a wild guess.
yes, it should be the function of these. In fact, these are some of the questions that you might get in those interviews. Why now? Why do you import these now? Um, so the importance of importing these trained underscore test underscore split is just to divide our data set into a trained set and a test set. Yesterday we didn't use these because we just had was it 6 rows of data, but today we have 50 entries. So we can divide our data set into some part to train the model and some part to test our model. So the next thing that I want us to the next thing I want us to do here is you notice that if I was to check the df dot head of our data here, let me just try to run these. You notice that we want to train our data set using the sepal length, the sepal width, the petal length, and the petal width part of the data, right? So meaning that this is the data that we should pass in that we should use in our model. So the target and the flower underscore name. We are not like going to this one is just going like to be the target variable. In fact, these are the two columns we have here. These are what we are calling the labels. I don't know if you guys you are remembering that. We say that in supervised machine learning, you must pass the data and the labels, right? So the sepal length, sepal wing, and petal wing, petal length, and petal wing. They are part of the data and even the target up to this point. But now we have the label for these. You know, these are the zero represent a setosa, one represent a Z virginica, and the other one represent a vascula. So these are the labels for a data set. So we should now divide our we should again now try um, to drop this is the now the target and flower name from our x values here. So we are going to have x, something called x. We can have a variable called x, and we have df dot drop the target and the flower name that is on the x columns, and then we are going to have our y-axis having the df dot target. So if I try maybe now to print the x, let me do the print so that you guys you can understand what you're trying to do here. Uh, I think you have. Let me just try to remove these. And now you can see that for the eggs, we have the sepal wing, petal length, and the petal length and the wing, right? And then for the targets now, of course, you know, of course, for the target now we have the zeros and one and two. Um, Let me just try to use the tail here so that you can see that in the target column we have the zeros and one and two to act as our labels. So I think this is it. Now from this data set here, we want to divide these. That for the x values, we want to divide them into train and test, and for our labels again, we want to divide them into train and test. And that is what you're going to do next here. So let me just maybe try to execute these. So that now we can have our next step is let me have these dividing maybe subset, which is the proper word to use. Let me just use divide dataset to test and train set. That is for the x values and the y values. So basically what we are trying to do here is just trying to divide, we are giving for the x values that we have here. We must have the x train. This one will be the data that we are going to train our model with. And then we are going now to have the text, the x underscore test. This is the data that we are going to test our model after we trained our model. I think you guys you can remember what we were doing. So we first have the x train, we train the model, the SVM model with. And then this test is the data set that we are going to again to use during the testing of our model. So basically that is what we are doing. You notice that we have 4 variables here. That is the x underscore train, x underscore test, y underscore train, and y underscore test. We are equating these one to what we imported here. That is train underscore test underscore split. So this is just like going to help us to split the data. And you notice that some of the parameters that we are passing in here is the x values and the y values, and we want to specify the test size of our data set, right? And we say that 0.2 represent what? That is the 20% of 20% of the data will be used to do what? Will be used to just try to will be used to test our model. Let me just try to let me just copy these here. Will be used to test our model. I think that is it. So now with this data, I think you can maybe check the. Let me just show you something here. We can check the length of the X train, and you can see that out of 150, the X train has 120, which is about, is it 80%? I think this is 80% of the whole data set. And we have the length of the X test, the length of Y train, and the length of the Y test. I think if we run these, we should be able to get those. Values. You can see that the Y test is the Y test is 30. Let me just try to comment on this. Let's see the X test. Oops, why are we getting 30 again? Yes, of course we should get 30 because 20% of all the test data set is supposed to be 20%, because I think we indicated that here. So when now you take 30 plus what we had here, but we had 120 here, and this one is 30, should add up to 150. So that is how we do it. Let me just comment out this. So after dividing our data set, I think the next thing is to create the model. So let me have a cell that will let me have a new cell here that will have our model here. So the SVM model. Should be like that, the SVM model. And the SVM model is just quite easy because we're just going maybe to, we're going to import this. This is from, oops. This is from sklearn. It's just right here from sklearn.svm. We want to import the SVC, the SVC model. And in fact, yeah, in the repository is called the SVC model. and that is and now we are creating an instance of the SVC model. So model is equals to this. So after this, we can have the training part of training our model. Now let's train the model uh, with the train data set. And if you guys, you can remember, there is this function that we use that is called fit to train the models. So we have the model fit, and we are fitting our model with that is with the X train and Y train, right? So we have these. I think if we run these, we should have a train model. So let's give it some times to train. Yeah, I think it's trained. So and now the best thing we can the next thing that we can do is to test our model. Let's check the you can let's maybe try to check the model score. Um, let me just have a new cell here. That we are going to have model dot we want to get the score. In this case, we're just going to pass the X test and Y test. So let's see the value that we are getting here. And we are getting 100%. The one, this is 1.0. 1.0. When you multiply this one by 100, you are supposed to get a score of 100%. This one is perfect. So it means that anytime we try to predict using this model, we are supposed to get we are supposed to get a perfect classification. I think we can give it some data to predict. But by the way, this one will not always be the case where you have your model where you have your model is getting an accuracy score of 100%. So yeah, so let me just try to predict something here, and we can have model dot predict. Let's give it some values here. We can have a value of 4.8, 3.0, 1.5, and something like 0.3. You can have something like this. So we are supposed to be dot predict. And let's see this kind of let's see what is going to be the output of this. And we can see that this one is classified as acetosa. We can maybe try to pick some points here that we already know the output. So let's pick the first row of data here, just to check if this model is going to predict correctly. So let me just pick that. That is what I should paste here. And you can see that this one has been classified perfectly. So, because we are getting a value of 0, it's classified at 0, and 0 is setosa, right? Let's maybe try to give it a different category. Let's use the tail function here to get the last few lines of data. Why don't we try to give it these data? That is the last value here. Let's see if it can predict these. There should be 4 values. That is the petal and the sepal length and width. So let's try to do this. And you can see that this one is classified as a S2, which is a virginica in this case. So any question? Do you have any question on how we implement the SVM model? Okay, thumbs up if you guys you got that. Yeah, I can see most of us are okay with that. So because of time, I think there is something that maybe we can check these. We can check this tomorrow. This model was perfect. That is 100% accuracy score. But this is not always the case. So if maybe you get a data set that is not maybe straightforward, you might even get an accuracy score of 0 point maybe 67, or maybe you can get even as low as what? It can go as low as maybe even 50%. So, but now what do you do in those cases? We have something we call hyperparameter tuning, and that is what I think we are going to check. We are going to check tomorrow. That is where we are going to start from tomorrow. So we see how you can tune your parameters so that you can at least get an accuracy score, maybe something to do with 90 and above for accurate classification. So tomorrow we are going to check how you can tune your parameters using something we call regularization, and also you're going to check gamma. It's something we call the kernels that are used uh, to tune your parameters. So, any question? Do you have any question? Yes, I think we have a question. Um, is it a question, Radovan?
Like, what are some of the factors which like can lead to the model score not being 100%?
There are so many factors. one of them being using maybe a data set that is not clean. You can have maybe a data set. You notice that in this case, you can have a data set that is quite it's quite not easy to do the classification. Let me show you that.